Okay, welcome. Today we're going to look at graphing higher degree polynomials using end behaviors. So let's go ahead and get our notes out and we'll get going. Remember, during this video, if you fall behind, pause the video and get caught back up in your notes. Or if you didn't quite understand something the first time, make sure you rewind it and listen to it again. Sometimes it takes a couple times through to understand the concept. Okay, let's go ahead and get going. What we have here are two polynomials. Now these polynomials are already in a somewhat factored form, so that's going to be our starting point today. And the way we're going to do this is we're going to look for our zeros, or our x-intercepts, and we're also going to take a look at our end behaviors, which we learned yesterday. So let's go ahead and start with number one. Alright, if I look at number one, I can see that it's in a factored form. It says negative 0.5 times x plus 3 times x squared minus 4. So the first thing I want to find are my zeros. Alright, so because we're in a factored form, I can set each factor equal to 0 and I can solve. And that will give us a 0. So my first factor is x plus 3. And I didn't need my parentheses, but I wrote them anyway, but that's okay. So I can subtract 3 from both sides, and I can see my first 0, or x-intercept, occurs at x is equal to negative 3. My second factor is x squared minus 4. So I set it equal to 0, and I can see that would be x squared by solving is equal to 4, or x is equal to plus or minus 2. Okay, so what I have here is I have my three zeros, and I'm going to go ahead and plot those on the graph. So I have a 0 at positive 2, I have a 0 at negative 2, so 1, 2 over, and a 0 at negative 3. So step number 1 was to find our zeros. Okay, step number 2 is look at our end behaviors. Alright, so this is the skill we looked at yesterday, so let's go ahead and take a look and see what we have in our polynomial. So our end behaviors, in this case now, because we're in factored form, it's all about the leading term, and our leading term in this case will have to be multiplied together. So I'm going to multiply the negative 0.5 times the x, and then that times the x cubed. And that means my leading term will be negative 0.5 x cubed, plus a lot of other stuff we're not worried about. Now when I look at our leading term, I can see that it is negative and it is odd. And I remember my odd graphs, end behaviors, or what's happening at the end, go different directions. And because it's negative, it's going to be flipped. So on the left side, it's going to be heading up, and the right side, it's going to be heading down. So we're going to go over here and plot that. So I have my three zeros. On the left side, my end behavior of this graph is heading up, and my end behavior on the right side is heading down. Now this is just, remember, this is just a rough sketch. So remember, I don't know what's going on in here, but I do know my end behaviors, and I do know it crosses the x-axis at these points. So I'm going to go ahead and just bring this on down, go through the points, come back up, and go down. And I don't know how far down this goes. I don't know where the minimum is, and I don't know where this maximum is. But remember, this is a rough sketch, and now you have a general idea of what this looks like. And again, we did it by plotting our zeros, and we had to go find them. And then we looked at our end behaviors, graphed those, and just basically connect the dots. Let's take a look at another one quickly. Alright, so we're going to look at number 2, so go ahead and write number 2 down. Okay, number 2, we have a 4 times x squared plus 2x minus 8 times x squared minus 3x minus 10. So we're going to tackle this the same way. So what I'm going to do is I'm going to get rid of this, create some more room, and we'll start with finding our zeros. As we look for our zeros, again, we are in factored form, so we set each factor equal to 0 and solve. And in the beginning I said somewhat factored because as I look at this I can see that each of these two factors can be factored even more. So we're going to factor these completely. Now they are trinomials, so the factoring is quick and easy. The leading coefficient is 1, so I know this will be x and x. And factors of negative 8 that add up to positive 2 are going to be positive 4 and negative 2. That implies my zeros are negative 4 and positive 2. So there's two zeros. My other factor, again, leading coefficient is 1. It's a trinomial. So this 2 should be an easy factor. Our first term will be x and x. And factors of negative 10 add up to negative 3. That looks to be negative 5 and positive 2. So those are my factors, which implies my zeros will be 5 and negative 2. I now have my zeros. So just like the previous problem, all we need to do is plot them. So let's start with negative 4. So 1, 2, 3, 4. And we have a positive 2. 1, 2 puts us there. We have a positive 5. So 1, 2, 3, 4, 5. And a negative 2. 1, 2. What I know about my graph is it crosses the x-axis through these 4 points. Let's go look at the end behaviors. And when I look at the end behaviors again, it's all about the first term, so I'm going to multiply the coefficient to the first term in each of the two factors. So this is 4 times x squared, which means the end behavior of this function, if it were multiplied back together, would start with 4x to the 4th, plus a lot of other stuff. But again, we're only interested in our end behavior, or I'm sorry, my leading term for our end behaviors. And because our leading coefficient is positive and our power is even, I know both end behaviors are pointing the same direction, and the positive will make them point up. So our graph at the very, very ends will both be going up. So I'm going to come over here and I'm just simply going to say, okay, both sides are going up, just like this. And I'm going to roughly come down and sketch the point. So I'm going to go through this 0, come back around, go through this 0, come back around, and go through that 0, and hit my end behavior. Now remember again, I don't know where these minimums or this maximum goes. It could go way up here, or it could be barely off the line. But again, we're doing a rough sketch. So here's the approximate sketch of this function in factored form, or somewhat factored form. Again, we did it by plotting the zeros, or finding the zeros and plotting them, and then using what we know about end behaviors to figure out where the ends are, and just connecting the dots in between. Okay, I hope that helps in graphing polynomials. It's a start, and if you have any questions, make sure you jot them down on the side and ask me in class. Thank you.